In this lesson, we will see the accumulator pattern in its simplest form, adding up numbers. Suppose that you want to add up or accumulate 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared and so forth up to 1,000 squared. You could write a really long statement, but that would be silly. Instead, use two ideas. First, have a loop that goes 1,000 times. Second, have a variable, let's call it total, that starts at 0 and each time through the loop becomes what it was plus the next item to add to the total. Let's act that out. We start our variable total at 0. Then we add in 1 squared, which is 1, so our total becomes 0 plus 1, which is 1. Then we add in 2 squared, which is 4, so our total becomes 1 plus 4, which is 5. Then we add in 3 squared, which is 9, so our total becomes 5 plus 9, which is 14. Then we add in 4 squared, which is 16, so our total becomes 14 plus 16, which is 30. Then we add in 5 squared, which is 25, so our total becomes 30 plus 25, which is 55. Then we add in 6 squared, which is 36, so our total becomes 55 plus 36, which is 91, and so forth, until we add in 1,000 squared. Here is the code in Python. Notice the three key items. First, we used a range expression in a for statement to make the loop run the number of times that the problem required, 1,000 in this case. Second, we used a variable, which we chose to call total, and we initialized that variable to 0 before the loop. Third, inside the loop, we wrote a very strange-looking statement. Total equal sign, total plus some stuff. The key is to read that as total becomes what total was plus some stuff. Read that way, it makes perfect sense. Thus, when the loop ends, the variable total has as its value the accumulated sum. Let's see this loop in action in the debugger in Eclipse. Here is a program that includes our summing loop. I have put a breakpoint at the beginning of main so that we can single step through the entire program. First, main calls a testing function called test_sum_squares. Then, inside test_sum_squares, it calls the sum_squares function, sending it 6 as an argument. So, as expected, the debugger shows 6 as the value of the parameter n when we reach the beginning of sum squares. After line 35 is executed, the debugger shows us that total is 0, as we planned. When line 36, the beginning of the loop, is executed the first time, we see that variable k is set to 0. So, when line 37 is executed the first time, the expression k plus 1 squared is 0 plus 1 squared, which is 1, and total changes from 0 to 0 plus 1, which is 1. This brings us back to line 36. When it is executed the second time, we see that variable k increases to 1. So when line 37 is executed the second time, the expression k plus 1 squared is 1 plus 1 squared, which is 4, and total changes from 1 to 1 plus 4, which is 5. We return to line 36 again. This time, k increases to 2, and line 37 adds 2 plus 1 squared, or 9, to total, making it 14. We return to line 36 yet again. This time, k increases to 3, and line 37 adds 3 plus 1 squared, or 16, to total, making it become 30. We return to line 36 again. This time k increases to 4, and line 37 adds 4 plus 1 squared, or 25, to total, making it become 55. We return to 36 yet one more time. This time k increases to 5, and line 37 adds 5 plus 1 squared, or 36, to total, making it become 91. The loop is now run 6 times, so when we continue our program, the loop exits. The program continues to the return statement, which when executed returns 91 to the caller. Back at line 20, we complete the execution of line 20, which sets the variable total1 to 91, as the debugger confirms. Line 21 prints the result, also showing 91, over there in the console on the right. Line 23 initiates yet another call to sum squares, where this time n is set to 1000. In the new namespace, total is set to 0 again, and a similar process ensues. To summarize, the accumulator pattern for summing has 3 key features. First, we use a range expression in a for statement to make a loop run the number of times that the problem requires. Second, we initialize a variable called, say, total to 0 before the loop. Third, inside the loop, we write a statement of the form total total plus some stuff, where some stuff is the next item of whatever we want to accumulate in our sum. Then, after the loop ends, the variable total will have as its value the accumulated sum. Finally, a small point: avoid using the name sum as your variable for the total, as there already exists a built-in function called sum, and you overwrite that function if you use sum as a variable name. We will do lots more forms of accumulators soon, so be sure that you master the simplest summing form first.